If you were to create a Bluetooth low energy IoT design today, like right now, what would you create? If time and your bill of materials wasn't an issue, what would you design? I'd probably go the drone route. I'd like a way to deliver food scraps to my chickens without leaving the house. Wouldn't that be cool? But if any of you out there have successfully designed a BLE-connected IoT design, you know that this can be a tricky process. Well, folks, u-blox is here to help. Hi, I'm Amelia Dalton, host of Chalk Talk. In this episode of Chalk Talk, Magnus Johansson from u-blox and I investigate the primary challenges in building a BLE-connected IoT device. We explore the different system architectures, including wireless MCU designs and network coprocessors, and dig into the very first steps you should take to get your next BLE IoT product off the ground. And before we get started, don't forget to click that link. There you can find even more information about this topic from u-blox. Hi, Magnus. Thank you so much for joining me.
Thank you, Amelia. Nice to be here.
Excellent. So we're talking about how we can build our next BLE connected device. But Magnus, give us first a brief introduction to u-blox.
Yeah, so u-blox, we are a manufacturer of chips and modules for positioning and short range. So we're a Swiss company where the headquarters is in Tellville. It's just outside Zurich in Switzerland, but we have development offices and sales offices around the globe. So we have basically three pillars that we stand on. The first one is positioning. This is where we make GNSS chips and modules and deliver state-of-the-art accuracy and reliability. We also have a services organization that supports the positioning part. So the services organization provides real-time correction data to give this centimeter level position to the positioning modules. We also have a business unit called Short Range. This is where I work, and we focus on Wi-Fi and Bluetooth modules.
Excellent. Now, Magnus, when it comes to building a BLE connected IoT device, it's not an easy process, right?
Right. It's super difficult. I mean, many of our customers, they do it. Some of them have a harder time than others, but it's super tough because when you build a connected product, like an IoT product, first you have to define what kind of system architecture do you need, and that impacts what components you choose and so on. But you also have cost and size constraints that you need to consider, and antenna design is not a trivial thing. And you want your products to be future-proof. So, if you want to make new products after this first successful one, then you have to consider that as well. Then we get into software development. So it's not only hardware you need to consider, it's also software. And in some cases, when it's cost-driven, you might end up with a module or a chip with an SDK that you are not familiar with, or it's not really great. Believe me, we've seen both great SDKs and not so great. And then you have certifications and regulatory compliance like CRA. If you want to sell a product in Europe, you need to comply with CRA in the next year. So it's tough.
Sounds like it. Now, Magnus, let's take a drone application. Where would we start if we wanted to build a BLE connected drone application?
That's a good product to consider because it's complex. I mean, you need to identify what type of technologies you need. And for a drone, you would typically need a GNSS chip or a GPS chip or module to support it. It needs to know where it is. You need to be able to set waypoints and make it return to home. You also need some kind of method or way to transmit data. So you could go with Wi-Fi to transmit, for example, real-time video, and you have data transfer and control mechanism you need to support. So Wi-Fi is one option. And you need Bluetooth typically to be able to broadcast its remote identity that's required in some countries. And you have to be able to provision it and do the initial setup of the drone. But that's just the technology, right? You also need to consider if we were to make this drone, we want to have a fast time to market. we need to control our costs and make the product future-proof because we expect our first drone to be super great. And then, we want to make more drones and we don't want to make redesign. And of course, we want to avoid complexity because complexity, you get consequences of complexity, so to say.
Absolutely. Now, what kind of different architectures are we talking about? How should we explore the different options?
So you have one option using an RF transceiver. We call it host-based solution in u-blox. This is where you have a module with the connectivity, but basically you utilize the hardware capabilities of the module and everything runs on a powerful CPU, typically Linux-based, and you have all the drivers and the application running on that one. That's one option. Another option is to have a network coprocessor, and this is kind of the opposite to the host-based one. You have a module with connectivity, and you have software running on the module, and that takes care of all the connectivity. So when you develop your application, you don't have to consider the complexities of connectivity. And then you have an option, that is kind of in between, where you have wireless MCU. So that's a module with the RF, the connectivity, but you also implement in our case, the drone application would also run on the same module.
Magnus, can we look at the wireless MCU architecture a bit more? What specific u-blox solutions would you suggest using for this kind of application?
So first, I think we should consider if we want to go chip down or using a module. So a chip down solution, you would typically have a chip running, for example, Bluetooth. That's where your drone application would be hosted. And then you have a different chip that has the Wi-Fi capabilities. And then you have a GNSS chip. The downside with this solution is you don't utilize the benefits of the module, and you have to implement the software, both the connectivity software for the Wi-Fi and for the Bluetooth in these chips. And on top of that, you have to implement your drone application.
Okay, so what about using modules for this kind of architecture? What would that look like?
So with modules, you avoid all the certification times that takes time to certify. It also comes with could be quite big cost. So if you use a module, you kind of avoid that. You also avoid the antenna design and the RF problems. It's a much smoother ride to go with a module in that sense. In this example here, we have open CPU solutions, so you would still have to implement the software parts, but you get the hardware benefits of using a module.
So, Magnus, could we also explore network coprocessors here as well?
Yeah, this is the third option where we have software on the modules. So you still have your GNSS module with software in it. You have in our case, NORA W366. That's a Wi-Fi module that contains software for the Wi-Fi. And then you have NORA B266 that contains software for the Bluetooth. So all the connectivity is already handled, and you can focus on your drone application running on a separate MCU. It could be a quite small MCU because, all the connectivity stacks, they're pushed out to the modules. So this is a much easier way, and you have to do a lot less software development to get this running.
So, Magnus, can we chat about u-blox's wireless modules a bit more? What are the biggest benefits of these solutions?
So one is speed. When you buy a module, you get it certified, so you don't have to go through the certification process. Also, extra development, you have to design the PCB and the passives and then the antenna design and all of that. So speed is one. Cost is another. Again, certification comes with a cost. You have to pay for different country certifications and so on. It also takes time, and you need to instruct the lab. You have to get a good lab, and you have to have the expertise to instruct the lab on what to do and how to test. And then you want to have a properly tested device before you send it to the lab. So you need test equipment to do that. Another one is focus. You want to focus on in our case, the drone application, the USP we have for the drone. We don't want to focus on antenna design and RF plumbing. The third one is scale. So because we provide the certifications, We can certify it for newer countries and the customer doesn't have to focus on that. Or in our case, as drone developers, we don't have to focus it because if we buy a u-blox module, they certify it for new countries. And it's less of a risk because we do less in the product. So it's less of a risk for us as a drone developer because u-blox already took the risk and they made it.
All right. So talk to me about the advantages and disadvantages of chip on board and module design.
Yeah, so if you look at these two triangles on the left side, this is where you buy a chip and you need to do all this heavy lifting in terms of radio and certifications. And you typically need to have RF expertise in the house. Not all companies have that. It's also a very fragmented regulatory landscape. You need to know how to certify and what you need to provide in different countries. And as I mentioned before, it's a lengthy certification process. And again, you need to qualify more passives because if you buy a module, this is already done. So you need to qualify this and it adds to your BOM. You also need to do antenna selection. When you buy a module from u-blox, we already pre-certify a number of antennas. So if you just choose one of those, then you're good to go. Then you're certified. And as I mentioned again, you have to invest in equipment for radio testing, and that's quite expensive. If you buy a module, all of that is included.
So, Magnus, global certification is also a very important design concern to keep in mind here as well, right?
It is. And we do certify globally, I would say. So you can see here on the slide a number of different countries and that we certify all of our modules. And we always try to help customers if they want to certify in a new country.
Magnus, overall, what benefits do you think u-blox brings to the table when it comes to the design of these BLE connected applications?
It's not only u-blox who makes modules, but historically and also presently, we have great RF performance. So that's a USP for us. And we always do either industrial grade quality, that means, higher requirements, or automotive grade, which is even higher than that. So that's one thing. We also have the form factor policy. So we name our families. We have the Nina, Nora, Iris, etc. And that means that, it's pin compatible. So even if you use one module today and you want to upgrade, say, the next product, our next drone, then we can change the module to a more competent module. Or we want to do a cost down version, we can change the module, but we don't have to do redesign. And then since we include software in our modules, the short range modules, that helps for a rapid integration and the time to market.
Can we also discuss network coprocessor design as well? What does this approach give me versus wireless MCU-based design?
All right. So at this point, I think for our drone, we have selected to go with a module. Now we need to consider if we want to do wireless MCU, which means, no software on it. You just get the SDK, or you want to go with the software version. So it's kind of more the black box situation. If we go with the wireless MCU, we as a drone developer, we need to familiarize us with the SDK. So know what the SDK does and how it works and do some basic bring up. So get the Hello World application running. And then we have to think about security. Where do we store our certificates, our keys? How does it work? And implement that. We have to have some kind of middleware because when we do our next product, maybe on a different SDK, we don't want to redo everything. So we need some kind of abstraction layer. And then we might need some kind of clients to connect to different, say an MQTT broker or something. Then we need to integrate that. And we need to, make it production ready, implement all the tests. And once we've done that, yes, great, we can focus on our application, which is kind of the thing we only wanted to do, but we had to do everything else as well. And we have to test it all. But if you buy a module with the software on it, you don't have to do all of that because that's already included. And u-blox did it in the module. And basically you can focus on the application itself, the drone application, and just, implement testing and test cases for that application. So going with the software version gives you quite a lot of benefits. You have less code to write and test. You know that you have stable APIs. So when you move to a different platform, you have minimal porting to do, less security risks, and you only write the application once. And this gives you faster time to market, lower cost, and you future-proof your product.
So, Magnus, what kind of software support does u-blox offer for these kinds of designs?
So in our standalone modules, which is what we call these type of modules, we have a software called U-Connect Express. So we treat it as a real product, and it comes on most of these modules as variants. And this software is pre-flashed. So when the customer gets it, it's already there. They don't have to flash it in production. It's 80 command based, and it provides you with wireless connectivity, be it Wi-Fi or Bluetooth. Then on top of this, we have quite a few support products. We have a product called S-Center. This is a super easy to use application. It's a graphical application you run on your PC, and it basically lets you explore the capabilities of U-Connect Express without knowing any AT commands. You don't have to read any APIs. You can just click in the tool, and you can do all the things that is possible in U-Connect Express, like connecting to an MQTT broker, send out HTTP requests, all of that stuff. Then once you've done that and you want to try a bit more and start coding, you can use an open source client library that we provide called U6 Client. This is super lightweight, and it actually maps one-to-one with the capabilities of U-Connect Express. It's a C API, and you don't have to understand or know the AT commands that lies underneath. It's just a C API that you can use. And actually, we found out that if the customer uses AI to develop his app, AI has a way easier time to understand this library. Then we have something called U6 Toolbox. You can call it a Swiss company. So Swiss Army knife app for U-Connect Express modules. And this allows you to talk to the module. You have a wide range of features like, Wi-Fi analytics. If you have a Wi-Fi module, you have different types of diagnostics. You can do all of the things that you can do on the module through the app. And then lastly, we have U6 Tool, which is a cross-platform, kind of similar to S-Center, but not graphical. It's command line based. It's made in Python, so you can run it on most platforms. If you want to create your use case in a script, before you're starting to code actual code, you can try it out in a script and you just run it and see if your use case works.
All right, so walk me through how all of these tools work together.
So here you see an EVK with a module on top. And of course, the U-Connect Express runs on the module. Then you have the toolbox. This is the mobile app. So it's supported on Android and iPhone, and that talks to the U-Connect Express. You have S-Center and U6 Tool. Those are typically random from a PC connected to the EVK via the USB. And then the U6 client is embedded in our case, the drone application, but the application that runs on the host MCU.
If we move forward with a network coprocessor solution, what kind of benefits are we talking about when it comes specifically to time and cost?
It can be somewhat quantified. So let's say we go with this software solution, we choose a module. So we avoid the certification cost, and that can range from like 40K USD to 500K. And it differs a lot because if you have many bands, or you have Wi-Fi, you have Bluetooth, so it's a lot to certify. In our case, if we just talk about Bluetooth, we would probably be in the lower range. But if you have a complex Wi-Fi solution, you might end up somewhere else. And we also save on the design, so we don't have to design. That's a lot of cost. And if we select the software, then we don't have to do a lot of software development that I talked about. So that's the save. And we don't have to care about maintenance for the connectivity part of the application. You can imagine if you just have 1 month per year and do maintenance, you have bug fixes, so you might have to apply security patches and stuff like that. That adds up to a significant cost as well over time. If we look at the time perspective, doing a module, yes, we avoid the certification. That could be 3 months plus. Also don't have to do the design. 10 months depends, of course, how many people you put on it. So it varies, of course, but we don't have to spend time on it. And same thing goes for software. We don't have to spend time, so we save some time to get to the market.
So, Magnus, there are other important design concerns to keep in mind, right?
Exactly. Not everything can be quantified, so you have other values. I mentioned the form factor policy before, so that's useful if you want to upgrade to a newer version of a product. You can swap out the module to a newer module, but you don't have to redesign. Then you have the benefit of using our battle-hardened software. So it's, like I mentioned, pre-flashed in production. You don't want to flash in production as a customer because that's typically quite expensive and not everyone can do it. You utilize the stable, mature APIs we provide, and these have been tested in thousands of deployments. And we also provide regular updates. We try to keep a quarterly cadence with the updates, and we also do vulnerability scanning to make sure that, no new leaks have happened. So we monitor that. And if they do, well, we patch it and then we send out a new update of the software. And again, back to the regulatory compliance, we have an established network of authorized labs and we have expertise in-house and know how to deal with these labs. So that's something that's hard to quantify, but it's some benefit for the customer. We also provide CRA compliant modules. So that's the Cyber Resilience Act that will come in effect in Europe next year. So if you want to sell in Europe, you need to comply with this CRA. We define the support periods and updates according to that. And as I mentioned also previously, application portability. You can reuse, in our case, the drone application, even though we swap out modules.
So, what kind of options does u-blox offer for network coprocessors and wireless MCUs?
We offer many different options. Here I just mentioned the Bluetooth for NORA B2 that we selected for our drone. On the left-hand side, you see the network coprocessors with the software. So we have a NORA B266 that's with an internal antenna. And then we have a variant of that's called B261. That's when you want to go with an external antenna and, maybe use one of the pre-certified ones that we support. And then you have a B276 that's say scaled down version of B266. So it's less price point, you could say, but also less feature set, but that's okay in some situations. And then you have the corresponding wireless MCUs. So those are basically the same, but no software. So you have the possibility to utilize the full capacity of the module using Thread, Zigbee, and NFC if you want to do that, for example. And the variance here is mostly relating to the chip inside and the memory configurations. So different memory configurations for this.
So, what about short range radio solutions? What does u-blox offer in this case?
Yeah, so that was just the NORA B2, but we have, of course, a lot more. So on top here, you see the variants. We have the different products for Bluetooth. And then in the middle, you see for Wi-Fi, the multi-radio ones that supports both Wi-Fi and Bluetooth. And then on the right-hand side, you see the host-based modules, where we just use the RF parts and everything ran on the CPU and application processor. And then we have M2 cards if you just want that interface. We also have antenna boards for the use cases, direction finding use cases using Bluetooth, indoor positioning, and so on. That's what we have on the short range side, but of course we have a lot more on the positioning side as well. So now we selected, module with software, and we focused on NORA B2, but of course we also, chose that for the Wi-Fi part. And basically, thanks to this, we selected this. We cut the development time by months and potentially save hundreds of thousands of dollars during development. So that will probably be a great drone project.
I agree. Okay, so Magnus, if my audience is ready to get started, where should they begin?
It's super easy. You just need an EVK. So I would suggest you go to the u-blox website where you can acquire one, or you can go to one of the global distributors. They also have it. That's what you start with. And if you want to, you can download S-Center from GitHub. It's for free. And you can start play around with the EVK, and you don't have to read any manuals or nothing like that, understand APIs. You just click away in the app. But once you get familiar with it and you want to start coding, you can clone the U6 client repo also on GitHub, and you can start prototyping your application.
Fantastic. Well, Magnus, I think that's all I have time for today. Thank you so much for joining me.
Thank you, Amelia. Nice to be here.
And before we go, you didn't forget to click that link, did you? There you can find even more information about this topic from u-blox. For Chalk Talks, I'm Amelia Dalton from eejournal.com. For more Chalk Talks, head on over to the Chalk Talk section of EE Journal. You can't miss it, it's right across the top. Or head on over to YouTube, youtube.com/EEJournal.